Hi, I'm going to be explaining how to do statistical process control chart. This is an example that I took in class 2, and I hope you can understand it better because, if you're not able to catch up with what I did in class, this might be a good review. To the statistical process control chart, we have these examples. The background of this example is that let's assume that there are 3 lines that are producing Chevy volts every day, and say it starts at 9 o'clock in the morning and then it ends at 5 o'clock in the afternoon. And then every hour they are, say, manufacturing 10 Chevy volts, and you want to do the test and found that 200 miles per gallon efficiency was produced on average, and then line 2 210 miles per gallon, and line 3 185 miles per gallon. And then you did the same thing for all the lines, and you have the result right here. And you want to visualize this process and check if they are in control and doing the job right. You want to test it. So to do so, you want to use a statistical process control chart, and we are going to construct it together. The first thing that you want to do is you want to find the mean of 3 lines between 9 and 10 o'clock. So it's going to be average function of these lines, these 3 lines. So C4 to E4, it's your average, and these are means. And then you are going to do the same thing for the other hours, and you're just dragging them down like this, and then you have the result. And then another thing that you want to do is you want to also look at range, and range is defined as maximum minus minimum of the range. Then you can find the range automatically. So in this case, the range is 210 minus 185, which is 25. And the same formula are applied throughout the time periods. So you have this range. And then the next thing that you want to do is to find an X double bar. And X double bar is average of these averages. So X double bar means mean of sample means. Therefore, you are going to calculate the average of averages. So that's what we did here. So average of these averages is double bar. And then you want to find the average for range too. And here is the range. And that's called R bar. Right? If you have done that, then now what you can do is you can calculate X double bar control chart, and we need X double bar value here, and then we need upper control limit of X double bar chart, and then lower control limit. And X double bar is simply the mean of means right here, so you can just click on that. Upper control limit is the formula is X double bar plus A2 times R bar. That's the formula. So, and then the lower control limit is X double bar minus A2 times R bar. That's another formula for lower control limit. And in the same way, we have to work on R chart too. And we have R bar and upper control limit and lower control limit. And R bar is simply from here, R bar, and upper control limit is D4 times R bar and D3 times R bar. So now what you can do is try to find this A2 value and D4 value and D3 value. So therefore, we can try to locate A2 value and D4 value and then D3 value. And these are values that you can find from table S6.1, and it's also provided in my slide. So I'm going to look at it with you together. So now you want to find A2 value, D4 value, and D3 value. And if you go back to my slide here under lecture 5, I gave this slide, which is on slide 21 and table S6.1. This slide shows what the sample size is. Depending on the sample size, you have different factors for mean and upper range and low range. And here, remember that we have 3 lines. So either different size or different equipment or different processes. You want to count the number of processes or lines, then it's going to become your sample size. And we have 1, 2, 3, line 1 and 2, 3. So 3 lines, therefore our sample size is 3. So A2 value that corresponds to sample size 3 is 1.023. So you can type here 1.023. And then in the same way, if you look at D4 value, 2.574, 2.574, and D3 was 0. So you now found all the values for A2, D4, and D3. And now you are going to use this one to calculate upper control limit and lower control limit and X double bar values. So now we see, let's see here, upper control limit for X double bar is X double bar, which is right here, plus A2 times R bar. And R bar is right here. So that's going to be your upper control limit. And lower control limit is X double bar minus A2 times R bar. Okay. So you have 227.64 as upper control limit and 177.47 as lower control limit. And then you have here R bar times D4 as upper control limit. So D4 times R bar is your R chart upper control limit. And the same way, D3 times R bar is your lower control limit. Then now you have all these values for upper control limit and lower control limit for each of X chart, X bar chart, and R chart. So now this is the time to draw the graph. So first of all, mean chart. So just select mean column, which is F3 to F11, and go to Insert, and then Chart. You have Chart here, and among them choose Line Chart, and this graph is the one that we are looking for. So we have mean chart right here. And we need to specify the upper control limit, 227, and lower control limit, 177. So click on the y-axis and right-click and format axis. And the minimum value is 177. And maximum value is 227, right? And then hit enter. Then as you can see, it has now changed, 170 to 227. And then we also want to change the x-axis right here. It's not 127, so we need to change that to 9 to 10 o'clock and 10 to 11 and so forth. So right click, format axis. You want to try and find format axis. Oh, again, click on the axis first and then format axis. Then you go to oh, it seems like I made a mistake. It's not the place. So you right click and go to select data, and then horizontal category axis labels here. So click on this icon and then start time 9 to 16. Hit enter then. Then now, the axis changed from 1 to something and then now 9 to 16. And if you would like to change it to time, so 9 o'clock, 9 a.m., then 12 p.m. In this way, you understand that this is time. And then you want to also draw the control limits and center line. So let's do that. Go over here and go to insert, and then format. Here, insert shape and choose this line and 227 as your. Then you can change the color to say red, right? And then copy it, paste it in 177. The center line is 202.70, so 202.70 about here. And then you can also go to insert, and then again click on the chart first, and then go to insert and shapes, and choose this box, and you can right here like that, and right click, edit text, UCL, upper control limit. It's too big, so you can make it smaller. Right, now arrange the, okay. And then copy, paste, center line, and then lower control limit. So lower control limit, edit text, and edit text and center line. Then you have mean chart, and remember, as you can see, you have to interpret it, and it's between lower control limit and upper control limit. So I deleted the center line, 202 point something. This is the center line. So this mean chart looks very good. And next is range chart. Let's select a column first, and then go to insert and chart. Among the chart, you want to choose this line graph, and you have this mean chart right here. And again, take a look at this upper control, 62.74, lower control limit is 0. So let's draw it. I'm going to just copy this line and paste. I think you have to draw it again. So click on this chart, insert, and shape, and a line like that, and then 62 point 0.74. So around here, that's your upper control limit, and you can change the color again like that, and then maybe you can copy and paste. Then you have lower control limit, which is 0, and then you have center line, which is x bar is 24.375, so probably about here. And then you insert text box here. So here's text box, and then right click, edit text, UCL, copy and paste. Uh-oh. Center line and lower control limit. Now you have range chart, right? So when you are judging this process, you have to look at both mean chart and range chart. As you can see, mean chart is oscillating around the center line, and no point is going beyond this upper control limit or lower control limit, which is a good sign. However, range chart shows that, at 3, I need to change this. So let's see what happened. Select data and horizontal line and choose start time. Then you have the time here. So at around 11 o'clock, we see that something happened and it's not stable. So the conclusion that you can make is, as a manager, you see that there's some problem at 11 o'clock and this whole process is not stable, and you want to investigate what happened at 11 o'clock. So let's go to 11 here, 11, 12. Now between this time, line 1, 180 miles per gallon. Line 2, 170 miles per gallon. Line 3, 240 miles per gallon. So line 1 and line 2 underperformed severely because the average 202 and their performance is very low, 180 and 170. However, line 3 somehow did a great job, achieved 240 miles per gallon. So that was a very good thing to see. So we see that line 1 and line 2 somehow did not perform very well, and you have to understand or ask the production manager or production people there what happened at 11 o'clock. While in line 3, 240 miles per gallon was achieved, so you want to understand that too. If possible, replicate line 3. Among all these performance, 240 was the highest, and how come 11 and 12, between 11 and 12, this much performance was achieved? You want to understand that, and if possible, you want to replicate that, make it a benchmark, and then do your best to repeat this achievement. And another question that I might be asking if I was a production manager is that, am I satisfied? Am I satisfied with this process? Although the mean and range is pretty stable except for this 11 o'clock, we need to see that it is quite stable process. So I would be happy with that. However, we're considering that Chevy Volt was promising that it's going to achieve 230 miles per gallon according to the marketing campaign. The center line is only 202, so this one has to go at least 30 miles above so that they can deliver the marketing promise. That has to be done. Okay, so this is a statistical process control chart and how to interpret it. I hope this was helpful for your understanding.